All right, folks, let's dive in here. Today we're going to talk about adding and subtracting polynomials, just adding on to what we were doing yesterday. This is still pretty review-ish stuff, so I'm hoping you find it not too difficult. All right, this is a couple of problems from yesterday, just working out what we were doing yesterday as a little practice. And it says here, watch to make sure. What should we watch and make sure of? That all of these variable exponents are exactly the same. If I'm going to combine, so simplify means to put this stuff together. So I need to be really careful and make sure that anything that goes with that is exactly an x3y squared, okay? There's another one that matches, so that'll go together. That is not, that's an x squared, not an x3y squared, so you wouldn't use it. Okay, so just make sure you're careful to match things up, okay? This x squared can't go with that, it's just an x. It has to go with other x squareds. I think you get the idea, x's with x's. So watch to make sure on those details, to make sure that variables and exponents match exactly. Okay, so to say it again, I think it was said yesterday, something like an x squared y is not a like term with x y squared. Okay, you cannot put those together. They are not like. So be careful about that detail when you work. All right, the way I would work on these is just pull them down. And we always want to put things into standard form. So make sure when you write it, I already wrote the quiz and I'm going to require everything to be in standard form. I said yesterday it's not a big deal if you don't, and mathematically it's not. But since we're learning this skill, I'm going to have you do it on all the problems in this unit to practice, okay? So I'm just going to start and I'm going to go with the first one. Negative 7 x cubed y squared goes with that other x cubed y squared, and it's negative 7 and positive 7. That means they cancel. That means they go away. And there are no x cubes y squareds left. I will see this often with kids, and that's wrong, okay? Not that. It is also not that. That is also wrong, okay? That's a 1. If we leave it like that, you're telling me that there's one x cubed y squared left, but there isn't. A negative 7 and positive 7 cancel and kill each other, so there is nothing left there, okay? Need to make sure to do that. All right, next I'll go to my squareds. There's my 8 and negative 7. So I've got some x squareds, and that 8 minus 7 is 1. You can write 1x squared, but I want you to get into the habit of just coming to x squared, okay? So we're using these polynomial problems to kind of practice on those little things. Make sure you're writing these correctly. Moving on, I've got x's and x's. And what do I have? I have negative 17 and 11. That's a subtraction. They're 6 apart from each other, and then we're more bad guys, so negative 6. And that's it, x squared. Minus 6x. If we want to check, make sure we're in standard form, I have the higher exponent first and the lower exponent after that. So it is in standard form, it's done. You try the other one. I'll come behind you. Go. All right, let's look at this. I see some P3 Q4s, and there's another P3 Q4. So I'll start with those. I'm really paying attention to the specifics so I don't get them wrong. And now I can worry about the coefficients. A negative 13 and a negative 6, so that's negative 19. Go into the next one. Q4s, let's see, yep, there's another Q4. And that's a 7 and negative 7 Q4. That's a canceling pair. So there's nothing there more to do. They're done. They're just canceled out. Going to the next. P2 Q2s. There's some more P2 Q2s. Let's do those. P2 or P squared, Q squared. We've got negative 11 and 10, so that's going to be a negative 1. right? A negative 11, 11 bad guys, 10 good guys is negative 1. You don't need to write the 1. You can just write minus p squared q squared. There's always the invisible 1 there. And that was everybody. So now let's make sure we're in standard form, and we are, because the highest exponent is in the front, and these are lower, okay? So whatever's to the fourth would be the front, and these only come to the second power, so they'd go behind. We're good to go. All right, moving on. We already did addition on the last page. Everything here, all those terms are adding with each other. So we could literally turn these problems into stuff on the next page by just putting brackets like that with a plus sign in between. And that doesn't change the problem. It's the exact same answer. It's the exact same problem. Today we're going to look at adding polynomials, which is actually just review. It's just looking at it. It may look a little different, but this is all review for you guys. The only difference is this. Okay, you may not be used to seeing these on here, but it doesn't change anything about what you do, okay? So it's basically telling you we have that quantity, a negative 6x squared plus a 9y, and we have that quantity. And all those parentheses are telling you is maybe they came from two different sources. Like a word problem might give you the first polynomial and say that's company A, the second one is company B, add them together. So that's all the parentheses mean, is they just came from two different places, and we're going to add them, okay? Notice there's nothing you need to do for addition. When you see there's a plus in between, that's all right. I'm just looking for like things to put together. There's some x squareds. We'll work on those. Negative 6 and 8. So I'm going to have 2 x squareds. And just keep going. Now I've got some y's. There's some more y's. I'll put those together. 9 and 6 is 15 y's. And all I've got left is some xy's. There's nothing to put those together with, so I'll just bring them down. Notice for addition, there's nothing special about those parentheses, okay? Now, are we in standard form? Yeah, technically we are. But I want you guys to also notice that the red term has the xy, so that probably should be in the front because there's multiple variables there. But if you leave it like this, it's fine because we do have the squared variable in front and the other ones are not squared, so they would go behind. We'll leave it like that. That's fine. Now, up top I said adding versus distributing. Notice this is a little different than what we might see other times. You might see something like okay, and if we see that, that is a different problem because that 3 is right next to those parentheses. And the whole purpose of the parentheses with a value right next to them is telling us we need to multiply. Multiply. Goodness gracious, my spelling is going away. Okay, so that's this. We've done before. We end up with that 15x squared and that negative 18x. Okay? If you see that, you need to distribute. But that is not what we're doing over here. A plus sign doesn't need to distribute. It's not a value. It's not a negative. So nothing would change. If we thought about distributing, it's not going to do anything. They're all going to stay exactly the same. So we don't need to distribute. We can just do an addition problem. Right? Second one. Real quick, with less talking, let's go through it. Negative 18, 17, negative 1. I'm just going to put negative x squared y's. Now I'll look for xy's. There's some matching xy's. 11 minus 9 is 2. Positive 2 on my xy's. There's some x's, and it looks like everything's been taken care of. Notice also, because I'm color coordinating or writing something on each term, you can tell when they're all done. You guys might, with just a pencil on your practice or on a quiz, you might want to go through and as you use each one, cross them out. And then by the time you get here and use it, you know you've used all the terms and nothing gets left behind. Double check. Yep. highest exponent and variables in the front. So I'm good to go with standard form. Right, there's one for you. Give it a shot. Go. All right, let's look. I've got my x4, y3s. That one almost got me for a sec. I saw an x and a 3, but that's not matching, so that's not where I go. x4, y3, -7 and -8, that's a -15 for my x4, y3s. Since I used them, I'm going to cross them out. Next, I'll look for some x cubed y's. There's one right there, 11 minus 14, that's a -3. Those guys were used. And now I've got a -7xy and a +7xy. But you know what? Those are canceling each other out. They're an opposite pair. So they go away and they don't come into the answer. And yep, we're in standard form because the higher variable's in the front. Actually, it's not about the 3, it's just about that 4. It's higher than anything in the other term. There you go. Now let's look at subtracting. And again, this is something we've already done before. It brings in that idea of distributing your negative. Okay? Now, in this first problem up top, there's just that one value. So literally, these are exactly the same. If I rewrote this guy, and I can just remove the parentheses, they're exactly the same. Look at those two and notice they're identical. All I did was take off the parentheses. And that's true. That's just a first term, whatever it is, minus the second term. So I would work this out just like it looks. Okay, bad guys and bad guys. That's a group of bad guys. That's a group of bad guys. So -14, -8, -22, x cubed, y. But if we look at the second practice problem, I've got a negative in between, and we're saying that everything in this first polynomial, that binomial there, and then take away or subtract off everything in the second one. Now, when we talk about subtracting everything off multiple terms, another way to say that is take their opposite. So the way we keep this from being confusing is we distribute that negative. Okay, which brings us over to this note over here. Remember, you want to rewrite the problem as addition and then solve it, okay? Wait until after you've rewritten it, which is what this idea of distributing will do, okay? If we distribute the negative and everybody's sign flips, it'll be rewritten as an addition problem, and then you solve it just like you solved it before. Okay, so the negative will distribute through. That'll become a -7x squared y because he was positive. Now that -14 flips, becomes positive 14xy squared, and that -19 becomes positive 19y. Shortcut version, notice all you did was switch the sign of each of those three. And because you did that, that negative goes away. Classic mistake I see that kids will make here is they'll keep this negative in the problem, okay? Don't do that. The whole point of distributing that negative right there is to have him go away. We simplified things. The negative has now been put inside of each of those three terms. It flipped their sign, and so now it's just a basic addition problem. Okay, I just copied down the first term. Nothing changes on the first term on a subtraction problem or an addition problem. It always stays as it's supposed to be, as it was originally. Now, if you want, you can connect them all right now, just as a simplified problem at the very beginning. We can just start doing this. Or if it makes sense to you, you could think of it as an adding polynomials problem. Now that we've distributed the negative, it becomes a positive, and you still go through and connect everything. Notice it's the same either way, whatever makes the most sense to you. And then I just start connecting all these guys together. Those are some x squared y's, -6, -7. Okay, used them. Now I've got some x, y squareds. Ooh, I think I was trying to trick you. Watch out for that, okay? Notice that's different from the x squared y in front of it. So now I've got an 8 and a 14. It's now a plus 14. So it's positive 22 xy squared. And finally, that 19y's got nobody, so I'm just going to bring him down right here and then cancel him so I don't get confused. I already used those guys. Everything was used, and I can check to make sure I'm in standard form, and I am. There's nothing higher than a squared on any of those other ones, so we're good to go. And there you go, okay? So notice, all we're doing, if we're given subtraction, is it's just a distributing problem. Distribute that negative, just like you would distribute a value. And once all those signs are flipped, then you just combine all those terms like an addition problem. This may look familiar to some of you guys. We've done a lot of this recently where you've got in like systems of equations. You might have something like that, and you need to solve from the positive y or negative y to positive y. You do that by just flipping everyone's signs, okay? It's the exact same idea. We're flipping the sign of each term in the equation to rewrite it. It's the exact same idea here. When you distribute, you're flipping the sign of each term in that second polynomial. But notice it's only the second one, only the back side. All right, there's a couple of them for you to try. Give them a shot. Okay, let's see how you're doing. Now, there's no need to distribute here, although you could. If you wanted to think of it as distribute the negative and flip that to negative 17 and make it an addition problem, that'll work out perfectly fine. Or you can just think of it as a minus 17. Either way works. There's no real issue of confusing it as long as we remember that's a minus 17 there when you combine them, okay? So negative 27 and negative 17. PQ4, and what is that? 37, 44. Negative 44, PQ4, and those guys are gone, and all that's left is that 18 PQ, so we'll put him on the end. Okay, the second one is multiple terms, so we definitely want to distribute the negative so we don't get confused and we don't forget. And by the way, I'm writing it right in the problem. If you guys are neat and it's clear to me what you're doing, I'm okay if you do that. Only if you're clear and neat, though, okay? Those arrows tell me there's distributing going on, so that's kind of what helps. If you just rewrite everything the correct way without arrows, I won't know on a quiz if you just wrote it, like copied it incorrectly or distributed or what, so you're going to lose points. So make it clear you flipped all those signs. All right, P3Q. For a second, I thought those might go together, but they don't. Did some of you put them together? Because they don't match. P3Q is over here. That's a negative 19 plus 8 and negative 11. P3Q. Those guys are both used. Now I've got a PQ3. That's the second one. Make sure those match up correctly. Okay, those are PQ3s, and that's a plus 11 and minus 11. Oh, I didn't need to write anything. That's a zero pair that cancels itself out. Okay, last one, I'll use a different color. I probably should have done that before. Got my P's and P's, negative 8, negative 9, that's negative 17. P, it is in standard form because the higher level exponent is in the front. All right, there you go. Okay, let's do a little bit of a geometry crossover here. We've been pretty focused, pretty narrowly focused recently on whatever we're doing in each unit, but we should be bringing in some other stuff. So let's remember perimeter. Hopefully that sounds vaguely familiar. Perimeter is distance around, that's the important piece of perimeter, around square or rectangle, whatever you're working with. Or triangle. Okay, it doesn't matter the shape. If it's got sides, we're counting what the distance around it is. So perimeter is just saying how far is that, plus that, plus that, plus that. This should sound familiar. You guys have probably been learning this since 3rd grade. Okay, so perimeter is an addition problem where you're just adding together all your sides. And remember, in a rectangle or a square, you've always got sides that are width, and you get sides that are length. So they'll talk a lot in these types of problems about L for length and W for width, okay? So let's do a couple practice here. Let's do this first one. If the length is 8 and width is 9, what is the perimeter of that rectangle? Well, if we're going to draw it out, let's see what we're talking about. So we've got length of 8 and width of 9. This is poorly drawn because it looks a little bit off, but you get the idea. 8 on the length, 9 on the width, which tells us both sides. Notice that. If one of the lengths is 8, that actually means both lengths are 8. If one length or one width is 9, we know both of them. So to solve this is as simple as the 8 plus the 8 plus a 9 and another 9. So we got a 16 and an 18. What is that? 34. Okay, and if that makes sense, look at it that way. But I do want to show you another way to look at it. Another way to look at it, which I think is going to be more helpful to you, is we're going to have 8 is our width, and we have 2 of those 8s. Okay? And then we have 2 of the 9s, the lengths, or whatever, whichever is which. Okay? So we have 2 of the 8s and 2 of the 9s. And from that, we can also see 16, 18, and get that 34. Okay? Pretty straightforward. What if we took that and applied it into polynomials? What if we went over here? If the length is a 2x plus 1 and the width is a 3x minus 7, what is the perimeter? Well, let's draw it up and see what we're saying. So we've got a length of a 2x plus 1 and a 3x minus 7 for the width. And so we need 2 of this, 1, 2 of the 2x plus 1, and we need 1, 2 of the 3x minus 7. So let's write that up. We've got 2 of the 2x plus 1. And we're going to add that together. All 4 sides add together. 2 of the 3x plus 7. I was looking around just now and I realized we didn't actually write that. Let's write that definition for you. Perimeter equals 2 times the length plus 2 times the width. You're just adding up the 4 sides, or you could look at it as length plus width plus width. Same thing, okay? But if we do look at it as 2 lengths plus 2 widths, it can help us on this problem we're working right now, and it ends up just being a distributing problem. So 2 times 2x, we have 4x plus 2. Notice it's a simple distributing problem. And then we keep going. 2 times 3x is 6x minus 14. A simple distributing problem. Now, if we stop right here, we are correct up to this point, but we didn't finish. What more could we do to this problem? Hopefully, you're saying, well, exactly what we've done the rest of this whole lesson today. It's just a polynomial to put together. 4x and 6x, 10x, 2 minus 14, negative 12. All right, why don't you guys try right now, and let's give you some new values. All right, there you go. You guys try that one. Okay, so notice, I would even maybe leave this on while you're working right now. There's your length, there's your width, You draw that up, which if you are not 100% clear on this, you should do. Right? There's your length. There's 2 of those. There's your width. There's 2 of those. So then write this out. You're going to have 2 of your length and 2 of your width, and then combine all that together to get your final polynomial answer. Finish up. All right, let's check and see. I don't know which was length and width this was, so we'll do the 4p minus 5 right here, and 2 of the 6p plus 2. So if I distribute, I've got 8p minus 10, and I've got a 12p plus 4, and now this is just simplifying. And again, if you wanted to, you guys could even throw parentheses right here, and it's as if we're adding those 2 quantities together, but because it's addition, nothing changes. There's no negative to distribute, it's just simply combining and simplifying. 8 and 12p, we got a 20p. Negative 10 and 4, we got a negative 6, and there we go. All right, homework practice. There's some photos that are going to be with the classroom assignment. You probably already saw them with the specific problems to do. Go do those.